Welcome back, students. In this video, we're going to cover lesson 7.6. This is trapezoids. It used to include kites, but they've removed that portion for this EOC. Excuse me. So we'll get started here. So properties of a trapezoid. So this is different than everything that kind of followed the parallelogram. It's not the same as the parallelogram. So, see, properties of a trapezoid. So it only has one pair of parallel sides. So, like right here, that would be those, and those are called bases. So we're just gonna put base. We're gonna call this a base. This is the whole thing. I should have wrote it bigger, but that's okay. And the non-parallel sides are called legs. So this would be a leg, and this would be a leg. A base angle is formed by the base and the leg. So that would be these guys, and then these guys. So they'd be consecutive rather than opposite, like everything we kind of usually deal with. All right, so base angles. So base angles are formed by the base and the leg at the top and the bottom. So properties of an isosceles trapezoid. Each pair of base angles is congruent. So that makes the legs congruent because the sides are congruent. It'd be just like the triangle when the two sides are congruent. The two base angles are congruent for the isosceles triangle as well. So each pair of base angles is congruent. So the tops and the bottom. The tops are congruent to each other. The bottoms are congruent to each other. And the diagonals are congruent. And therefore the legs are congruent because of those base angles. All right, so example 1. And here, so we have an example and we have 3 parts to it. Then we don't have a 2. So there's no you do. It's going to be a me do here on number 1. Let's see. All right, so the medical sign shown is a trapezoidal prism. All right, the front face of the sign is an isosceles trapezoid. So WX, so that's this guy up here, is 2x minus 2. And let's see, YZ is 2x plus 6. WZ is 4x plus 5, and YZ is 5x minus 3. Okay. So part A wants us to prove that x equals 8. All right, so you can do this a couple of different ways. We're going to try to make it easy. So remember, if this is isosceles trapezoid, it means these guys are going to be congruent. So you could either put them equal to each other and solve and make sure you get 8, or plug it in and make sure 8's the same number. I'm going to do the mental math here. So say 8 times 4 is 32. 32 plus 5 is 37. Over here, 8 times 5 is 40. 40 minus 3 is 37. So x does equal 8, but because that's how we do things, to prove x equals 8, we're going to put WZ equal to XY. So 4x plus 5 equals 5x minus 3. The angle thing we'll do over there. All right, so we're going to subtract 4x from both sides because it's the smaller. They cancel. 5's here. 5x minus 4x is just x, and then minus 3 comes along. Add 3. So x equals 5 plus 3, or 8. So there you go. But that's how you prove that x equals 8. All right, part B. Find the measure of angle Z if the measure of angle X is 106. So this is 106 degrees here. Now, remember, because this is a trapezoidal or an isosceles trapezoid, that means these guys are 106 And then these guys are congruent to one another. Well, remember, if we have four sides, a quadrilateral, the total for the interior angles is 360. So we split this kind of down the middle because these two are congruent and these two are congruent. So each half is 180. So angle Z equals 180 minus angle W. So that is 180 minus 106. So angle Z equals 74. Just double check me there. Yep, 74. Just double checking. This is part B. All right, C. Find the perimeter in front of the face in inches. So we already know that x equals 8. So when we added those together, this side was 37, this side was 37. We plug x in here, 8 for x, so 8 times 2 is 16, minus 2 is 14. 8 times, wait a minute. Yeah, that's right, they're not congruent, sorry. And then down here, 8 times 2 is 16, plus 6 is 22. So the perimeter is the four sides. So it's 14 at the top plus 22 at the bottom plus 37 on the left and 37 on the right because those two are congruent. Add all four of those together and your perimeter is 110 inches. Okay. All right. Example 3 at the bottom. This is the I do. You guys will have the practice 3 on the other side as you do. All right, so example 3, quadrilateral QRST has vertices and it gives us those coordinates. Show whether it's a trapezoid and determine whether or not it's an isosceles trapezoid. So let's go ahead first and plot our points. So we go -8, so 3, 4, 5, 6, and then -4, so down. So this is Q. R is 0, and then it goes up 8. 1, 2, 3, 4, 5, 6, 8. S is 6 to the right, and then 8 up. And then, so this is S, and then T is -6. And then -10. All right, so, goodness, excuse me just a minute. Gotta pause here, hold on. Okay, sorry about that. Had a little technical difficulty. Okay, so what we need to do is we got to check our slopes and see which ones of these are parallel. And I'm going to, let's see, QR, that's, okay, yeah, so we're going to check. It looks to me like these guys should be parallel. These, you see this goes this way, if they'll eventually cross here. So pretty sure QR and ST are our parallel sides, so it is a trapezoid, so we need to prove which sides are parallel, so then we can see if it is isosceles or not. So slope QR, so y's over x's, so slope is m equals rise over run, or y sub 2 over y sub 1 minus x sub 2 minus x sub 1. So QR, so we got our y's is 8 minus negative 4, or 8 plus 4, over x is 0 minus negative 8, or 0 plus 8. Going below, that's 12. 8 plus 4 is 12. 0 plus 8 is 8. That will break down. 4 goes into 8 2 times. I'm sorry. Yeah. 4 goes into 8 2 times. It goes into 12 3 times. So this is 3 halves. That's this. Switch pins. All right, ST. So you got negative 10 minus 8. And then negative 6 minus 6. Is that right? No. Yeah, negative 6 minus 6. So negative 10 and negative 8 make negative 18. Negative 6 and negative 6 make negative 12. Those negatives cancel. And so 4 goes, wait a minute. 6 goes into 12 2 times, and it goes into 18 3 times. And it's positive because, again, those two negatives cancel. So these are parallel sides. So I can do this. Now, so obviously these two are not the same length. It would be these two that would have to be the same length in order for it to be isosceles. So let's write over here. So QRST is we'll just wait. So we're going to check the length to see if these guys, they look pretty close. So distance is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So those are the square roots. That's for the distance. So we're going to do this for RS. So distance formula is x sub 1 minus x sub 2, so 6 minus 0 squared plus the y's 8 minus 8. All right, so show you this really quickly. 6 minus 0 is 6. 6 squared is 36. This is 0. 0 squared is 0. So it's just the square root of 36. And if you take the square root of 36, that is 6. So now let's look and see if QT over here is the same length. So QT, so negative 10 minus negative 4. So negative 10 plus 4. And then the other side is negative 6. Let me see, yeah, negative 6 minus negative 8, or negative 6 plus 8. So notice here, this is, so negative 10 and 4, so that makes negative 6, and negative 6 squared would be 36. But the problem is this is not 0 over here. This is 2. 2 squared is going to be 4. So this is going to be the square root of 40, which is a little bit bigger than the square root of 36. So this guy is a trapezoid, but not isosceles. So, and it's because RS is not congruent to QT. All right, let's flip the page. I hope, let me just back up so you can see the whole thing. So QRST is a trapezoid, but it's not isosceles, and it's because RS is not congruent to ST. We can check these, but they are not congruent, I can tell you, because this guy's straight. This one starts here. This one starts further away. Besides that, they're parallel, and you need these two to be congruent for it to be an isosceles trapezoid. So, flipping over. Got a little bit left to go. This is for you guys, so you're going to plot the points, draw it out, check to see, you're going to check slope. to figure out which ones are parallel, and then the ones that are not parallel. So then you use the distance for non-parallel sides. So, and when you do that, so if, don't write all this, you do the problem, but if the non-parallel sides are congruent, then it's an isosceles. If not congruent, then not isosceles. So you check it out, let me know. Mid-segment of a trapezoid. Sorry, your mid-segment, this is a segment that connects the midpoint. So midpoint, that means these two sides are congruent because it splits it into two equal pieces. And then the other side is going to be congruent because, again, this is the midpoint here and the midpoint over here. And so the trapezoid midpoint theorem, the mid-segment of the trapezoid is parallel to the bases. And so if this is B, if your mid-segment is B, it's A plus C divided by 2. It's the sum of these guys, half of the sum of these guys. So in this example, if this was 3 and this was 9, 3 plus 9 is 12. 12 divided by 2 is 6. So let me do this example. You guys will get the next one. In this one, they give you the mid-segment. They want the other. So Rn being the mid-segment, it's equal to 2 times Lm plus QP. Now, we have Rn. We have our mid-segment's 24. It's 2 times Lm, that's x, that's what we're looking for, plus QP 16.7. All right, so we're going to divide both sides by 2 to get rid of that. 24 divided by 2 is 12. So 12 equals x plus 16.7. Now, hold on, mess this up because I messed this up because it's not this is not 2 times this, it's half of that. So we would have multiplied both sides by 2. So 2 times 24 is 48. So it's Rn equals Lm plus QP divided by 2. So we had to multiply both sides by 2. So now we're going to subtract 16.7 from both sides. Apologize for all the confusion. And when we subtract those out, x equals 31.3. So 31.3 plus 16.7 is 48 divided by 2. You get 24. So below, I'm just going to go ahead and show you the formula. So this is your mid-segment. Mid-segment equals this guy, FG, plus the bottom guy, KJ, divided by 2. So you have this. Just plug it in. 15 equals x plus 18.2 divided by 2. So you're going to solve for x on that one. All right, last page of Module 7. I'm going to do 5. You guys are going to do the 5 check. So, for example 5, trapezoid ABCD over here, it tells us that AD is parallel to BC. Find the endpoints of the mid-segment. Okay, so let me just see. AD parallel to BC. And it is parallel to each base, so it's this. So, yeah, looks like I may have told you guys wrong in class. But we are going, because these two are parallel, we are going to find the midsegment of AB. Yeah, hold on. AB and DC. So midpoint is x. The x's divided by 2, the y's divided by 2. So for AB, so our x's are 0 plus 18 divided by 2. Our y's are 8 plus 8 divided by 2. DC, 1 plus 20. 1 plus 20 divided by 2. And the y's are 4 plus 0 divided by 2. So 18 divided by 2, because it's 18 plus 0 is 9. 8 plus 8 is 16 divided by 2. Obviously 8 plus 8, you're going to... And then over here, 1 plus 20, 21 divided by 2 is 10.5. 4 over 2 is 2. So let's plot these. Let's say, so 9, that's going to be between 8 and 10, you see. Then we go up to 8. So between 9 and 10 on line 8, that's that one. And the other one is 10 and a half, so not quite in the middle, and then up to 2. You see how this is right here. And then the mid segment goes straight across. Okay, you're going to do the same thing down here. If you have any questions, leave me a comment. If you do go to First Coast, send me a message on Focus or on Teams. Until next time, have a good night.